Hey, good morning. So, today what I'm going to be working on is driving progress on this betting project I have. Here's my Trello board here. I kind of wrote things I want to do on YouTube in the description of the stream, making sure the stream works. Um, last time the last stream I got a comment I didn't see. In the stream before I didn't get any comments. In the stream before that I got two comments I didn't see. So I'm really going to try to keep up on checking the comments here. Um, and I have the window here, so I'm going to try to keep all windows minimized so I see this as I'm working. So, uh, what do we want to do today? I forgot I put it in the description here. So, where's the Where is, oh, here's the description. Um, right, so I did spread. So yeah, where I left off last time, I was looking at how does the spread swing, and can we predict how the spread is going to swing based off of how the spread swung the previous weeks. Um, so looking at it here, um, swing and spread versus performance against spread. Okay, so we have this, and this is average. The X here is average performance against spread the last two games. Um, this is swing and spread this game on the Y, and then swing and spread, average swing and spread the previous games on the X. This is just for the last game. This is the average over the last two games, and this is the average over the last three games. How the spread swing is going. Uh, So yeah, so I guess kind of what I'm getting from this is I said we would go back to up to 4 weeks back, but we don't really see any patterns emerging. Here's 1 week back, 2 weeks back, 3 weeks back, and that's looking at spread swing versus previous spread swing. This one actually looks more centralized than any of them. Um, so uh, what I think is happening is that we don't have enough data. Just looking at how the spread is swinging isn't going to give us a good analysis. Um, now, uh, what do we want to do? So I want to look at how one team's performance against the spread changes throughout the season. We also want to get some more data, and in this stream, I'm going to try to set up a machine learning model to classify whether a bet will be good or bad. To classify it, we'll use how much money it makes if we bet it on the open and then bet it again on the close. Um, and is there anything else? No, that's pretty much it. So, um, do same analysis, but I'm performing with the spread, but with total. Right. So we want to, so I guess the first thing to do would be I want to do what I'm doing right now with the spread, but I want to do that with the total data. So we're not noticing um, any pattern in the spread swing, but now we want to look at, we don't want to just look at the spread swing, we want to look at the total swing and the odds swing. The odds swing is correlated with the spread swing, but they're not exactly the same. Um, so the first thing to do would be generalize this function so we could get any attribute. Spread. All right, so this I've finished. I actually didn't go back 4 weeks, but I'm going to say it's finished because when we go back 3 weeks, we don't see much of a pattern, and running that takes a little bit of time. So we could put that over there for now. If we decide we want to look at that later, um, we can do that. Try last n weeks spread input as neural network. Um, okay, that could work. Um, so this will work fine, but before we look at the neural network, we want to look at some simpler patterns. That's kind of over analyzing. Um, I have a sandwich on the way, so I have to check when that's supposed to come, and I gotta remember to check the chat. All right, so um, so we want to generalize our retrieval function, so we can get any value we want. Any value we want, and then get that out of there. And what are the values we want? Let's do a checklist. All right, so the first value to get is performance against spread. The performance against total. This is for each bet. So we also want to reorganize the data set so that we have a bunch of bets. But that'll be for later. So we want to get performance against spread, performance against total, swing in spread, swing in spread, swing in total. We also want to get swing in odds, how much the odds swing. There's no such thing as performance against odds. Okay, so let's exit out of here real quick, and we're going to add another to do. We want to reorganize data set to be in terms of bets. Or let's just say get new data set, get new data set where rows are bets. And because that is the data set that we're going to want to feed into the neural network. Now let's assign how important each of these tasks is. Figure out how to automatically define the desirable region. Look into machine learning to find regions to take bets in. Perform analysis on analysis 1 trends to see how performance does. Perform analysis 1 on analysis 1 trend 2. Or perform analysis on analysis 1 trend 2. Right. So that is probably higher priority than anything else. I guess I'll make red high priority. We could say critical, medium, low. All right. That's high priority, which is red. Create. Oh, get rid of the plain red one. And what's the green? Oh, right. All right, so that's high priority. Figure out how to automatically define the desirable region. That's part of the analysis. So let's make a to-do list. Figure out how to define desired region. Okay. Now we could get rid of this. How do we delete? Is it just archive? Look into machine learning to find regions to take bets in. We could get a more detailed thing for that. Look at how performance against spread does for each team in the season. Yeah, that, um, let's change it. So we don't want, look at how performance against spread. So let's say do performance against spread as well as performance against total. So we want to do both of those. Um, that I would say is also high priority. Speed up the code. Um, that's medium priority for now, but it could become high priority. It could become a bottleneck for us, but for now we'll say it's medium priority. Yellow, we can make medium priority. Get data from 538 and start doing analysis with it. Let's add in the URL for the data. I was there not that long ago. Well, let's just go to GitHub 538. Should pop up. Let's look at NFL. That's interesting. Ticket price data. NFL ELO. And this goes back to when. All right. So let's see when this data goes back to. The latest ELO. Okay, so they have it up to last season. And what about this one? How far does it go back? 1920? Wow. Wow, that's great. We could even make, this isn't, I want to see if anyone's ever done this. You could do how good each, I want to see over time. I want to see if I could make this video. If you guys have ever seen those videos where it's like performance over time. People make these videos. Man, I'm having trouble describing it. Let's see if we could find one. NFL best team over time. Best team since the beginning of the league. Best team. Oh man, my best team since beginning of league. Oh, this is a cool video if you've seen this. If you've never seen this, I watched that once. It was awesome. If you're an NFL fan. Yeah, I don't see it. So, this isn't even, make your description even better. Okay. Data, ELO, data available here. And the problem is, I'm pretty sure they get their ELO data from, I think they only have the ELO data for past seasons, and I'm pretty sure the ELO data comes from the NFL API. And I don't know how they calculate the ELO data. Does the NFL API give ELO data? NFL ELO data. So, I mean, if we build a model with this data, and then if we build a model with this data and then can't get any data for the current games, then there's not really a point. 538 has an admitted fondness for the ELO rating. So the ELO ratings are a 538 game. For any game between two teams with certain ELO ratings, they have their equation in LaTeX here that doesn't render on the page. So, now how do we... These charts will help you. Yeah, I guess they already have it here. This is cool. I guess I'm getting distracted here. I just want to see how the Seahawks have done over time. Yep, that was when we were the best. Early 2010s. The good old days, the early Pete years. Okay, so anyway. So we want to get the ELO rating. Now, do they release it? 538 ELO ratings. Current. Okay, so oh, ABC bought 538, I guess. That sucks. But smart for them. They get the best data. Um, okay, let's look in here. Basically, what I'm trying to do is find. Uh, that's interesting. I guess 538 is moving away from sports. Um, all right, so it looks like you can't get the ELO ratings anywhere. And this guy seems to be updating with the current ELOs on his Substack. Maybe later. Maybe later. All right. Hell yeah. NHL, damn it. Pro Football Reference. So, oh man, we could get his information, but we need to update it every week. Now, can we get the history of this? Maybe at the web archive? I guess it's just one way. Wayback Machine. All right, and let's see if we could find. Well, we have it for November 15th. The ELO ratings for November 15th. God dang it, man. Hopefully we could get past this authentication. That's not gonna work. Okay. Now let's look if there's a technique to get the ELO ratings. NFL ELO rating. Testing the ability of the surprisingly popular method. What does that even mean? Okay. This is from 2022. All right. I guess I can't view this. How to calculate NFL ELO ratings. This repository contains code and data to accompany historical NFL scores going back to 1920, code to generate the ELO win probabilities, game schedule and results. Oh man, this would be great if they had ELO code. Huh. Games equals util.read games, nf data slash forecast every game. Evaluate our forecasts against ELO. Util.evaluate forecasts. Okay. Evaluate score and forecasts. I have to check if my sandwich is here yet. Dun, dun, dun. Okay, so back to this. Does this give us the ELO? Rounded ELO prob equals round game of ELO prob 1. Damn it. Calculate ELO points. So game for game and forecasted games. Data. Okay, this doesn't help. Is this is NFL? What is that? Date, season, neutral, playoff, team 1, team 2, ELO 1, ELO 2, ELO prob 1, score 2. All right. Date, season 1920, neutral, playoff, team 1. Oh, okay. Team 2, ELO 1, ELO 2. So this doesn't tell us how to calculate the ELO score. NFL ELO score formula. Nice. Hopefully this guy does it. We're going to walk through the ELO rating calculation using data from the current 2019 NFL season. Let's take a look at the format of this data season. So all we have is the teams and the scores. The first step we need to take is create a column denoting whether the home team won, tied, or lost. How to calculate QB elo. Okay, so how do we calculate the elo of a QB? This doesn't tell us anything. Oh, nice. So I wonder how they get that. Nice. So below are the NFL elo. All right. And how has the model performed? Hmm. This is a nice site. I should follow this guy. NF Elo, NFL Analytics and Prediction. What's EPA? Man, these guys have some great stuff. QB create rate. Okay. Hmm. Opens predicting 62% of winners. So he's talking about his model performance. So this is interesting. Oh, can we download? Oh, cool. Let's go look at this data. Oh, what a nightmare. Why is downloading? Yeah, that is a CSV. Why does it download that way? Looks like it's downloading HTTP. It is. Um, in addition to the elegance and their simplicity, ELO rating systems also benefit from their ability to be extended and customized to the competitions they measure. This is exactly what NF ELO does. It's ELO for the NFL. NF ELO takes the core ELO framework and adds to it some models. Since ELO rating systems are not tailored to the NFL out of the box, a little more work needs to be done to make it actionable for different types of NFL betting and analysis. When ELO compares one team's rating to another, its prediction is expressed as a win probability for one side. In the case of NF ELO, it's also the home team win probability. Here's how NF ELO translates this win probability into different applications. Oh, EPA is expected points added. All right. The original ELO rating system. New rating equals previous rating. What? I don't really get that because it goes to a new line. Yeah. So new rating equals previous rating plus previous rating times times actual outcome minus expected outcome. So it's a modified formula. Man, this guy has a great site. Let's bookmark it. All right, so back to our project. So the 538 data isn't going to work. However, we could get ELO data using a different model. Man, we just got to get the model. That's the whole trouble, is getting the model. Of course, because he made this model. App/games. Don't want to download it. NFL power ratings. That's funny. The Browns perform by far the best defensively, but they just don't have a good offense. And the Niners are just great. What? So I guess this is just Patriots versus Jets. I guess this guy's a Patriots fan. All right. So our next thing is, can we calculate the ratings ourselves? How? No. Man. So we found ELO ratings. NFL ELO model. Gotta remember to check the chat. All right. Okay, it'll probably be behind a paywall because that's how everything is on Medium now. ELO ratings and betting strategy. Yep, back to that repo. All right. So we can't find ELO data. What other data can we find? That actually doesn't matter. This was a big sidetrack. get data from 538 and start doing analysis with it. And this is bottlenecked. All right, and that's bottlenecked until see if I can formulate my own ELO ratings. And this need to formulate my own ELO for historical ELO to have value. And this is a bottleneck reliever, and we can put it on low priority. And this is also low priority. And this is try last n week spread input as input to the neural net. That is also low priority. And that's bottlenecked for what? That's not bottlenecked. Get new data set where rows are bets. Also low priority. Okay. Generalize retrieval function so we can get any value we want. This is high priority, and that's what I'm going to do next. Okay, and what are the values we want? Performance against spread, performance against total, swing in spread, swing in total, swing in odds. Performance against spread, performance against total, swing in spread, swing in total, swing in odds. Is there anything else we want? Let's go look at the data real quick. Okay, yeah, is there anything else we want? Let's see. Home close odds, home open odds, road close odds, road open odds, closing total, opening total. So swing in total, and then also performance against total. Okay, we have performance against total. Swing in total, performance against spread, swing in spread, swing in odds. Game differential. Okay, so get this team's last N performance against spread, performance against total, swing in spread, swing in total, swing in odds, game differential. Okay, and see if I can. Medium priority. This I'm changing to low priority. All right. So generalize retrieval function so we can get any value we want. So that's what we're working on right now. Um, okay. Let's line up these windows so we can have them both at the same time. Okay, nice. Okay. Oh, nice. All right, my sandwich is here. I'm gonna go to the bathroom, grab my sandwich, and then I will be right back. BRB. Okay. Um, actually, I don't really need to mute anything. Okay, be right back. All right, so I've got my sandwich. Now it's time to retrieve data. Let's just make a new file. Um, can call it functions. All right, import pandas. Um, function for getting the function for getting relevant values for a team for the last n games. Um, class data handler. And that's going to be one of our functions in the data handler class. Started off, just say pass. Yeah, pass. So we want to retrieve that now. Yeah. How do we want to do this? How do we want to do this? Um, uh, I think it works fine as a function. All right, function for retrieving relevant values. Oops. So instead of specifying the value that we want to read in, we can just specify all of our things from here that we want to read. Performance against spread, performance against total, swing and spread, swing and total, swing and odds, and game differential. Is there anything else we want? We also want to get the opponent. No. Um, um, okay. So we also want to get opponent and then home, a true or false, Boolean for whether that team was home for that game. Opponent ID. Date doesn't really matter. Yeah, we have performance against total, performance against spread. Okay. So I'm trying to think. I guess we can just write the function so it reads out a dictionary with the data. So team, week, season, in num games, so that we can get the last n number of games. Okay, then data. I'm gonna read in our data. Oh, read Excel of data.xlsx. And then I'm actually gonna read in the data. I don't want to have to read in the data every time. We saw before that was cumbersome. Um, get previous spread performances. Hey, come on. Okay, so get previous spread performances, get performance against spread, team week to look for season. Buddy, come on. All right, so let's just start out with the same structure. So week to look for is equal to week minus 1. Um, Might as well retrieve, not, instead of saying go back num games, we could just say get the data for this game, for this team, week, and season. Um, we could say that data, now find, get performance against spread. Now, come on, buddy. My dog buddy wants a sandwich. He says, I really want a sandwich really bad. But buddy, I can't give you a sandwich. All right. So, buddy, stop. All right, so data is equal to that. Instead of year, it's season data dot data dot week is equal to week, and then data dot home team is equal to team. Data dot home team, and then data dot away team. All right, so this chops our data set down to just that week's game. Now, let's go over here. Add that onto the end. If data dot away team dot values dot item is equal to team. Okay, so if our team is the away team, then performance against spread is equal to data of road closed spread data of road closed spread. And then the result, performance against spread is spread plus result. So that's spread. So performance against spread is equal spread plus result. DF of away score, not DF. Gotta stop doing that. data plus data of away score minus data of home score. Okay. And it's this whole thing. So performance against spread is that whole thing dot values dot item. Hi, buddy. You're a good boy, but I'm not gonna give you any sandwich. Good boy, but I'm not gonna give you any sandwich. I love you. Um. All right. Now we have performance against spread. Buddy, stop. Good boy. Now performance against spread. What else do we want? Let's check the stream analytics real quick. See if anyone's watching. Still no one watching. That's okay. Oh, one view. That's nice. All right, so performance against spread. Now let's get performance against total. Is my name. So let's do, first we want to get data of closed total. Closing total. So data of closing total. Um, Data of away score plus home score minus data of closing total. Okay, now that's the same either way. Okay, performance against spread and total. Now we have swing and spread. Spread swing. Okay, swing and total. Spread swing, total swing. Okay, and then we're just going to add this on to the end of the next two lines. Then total swing is equal to, should already add that on the end, data of, I think, opening total, closing total. Opening total, close. Yep. So data of closing total minus data of opening. total. Okay. Um, total swing, odd swing. Road close odds, road open odds, road close odds. So road open odds minus data of road close odds. Now, performance against spread. Hmm. Need a paper towel. Hi, dogs. All right. So, all right, we got the swinging odds. Game differential. Okay. Game diff is equal to data of opponent opponent is equal to data of home underscore team. Data of home underscore team. And then home is equal to false. And then anything else we need? Opponent ID. Got it. Okay. Now we just need to write this for the home team. Otherwise, if it's the home team, then do this, and we'll just have to change a few things around. All right, so performance against spread, we're getting the home close spread again, and then plus data of away score minus data of home score. Yeah, so this should go to home. That should go to away. Okay, for spread swing, we just have to change it to get the home one. Same with the odds. And the game diff is opposite, so it's home minus road instead of road minus home. All right. And then the opponent is the away team. Should be away, not road. And then home is equal to true. Okay. Now we want to return performance against spread, spread swing, performance against spread. What? Oh, duh. Performance against spread, performance against total, spread swing, total swing, odds swing, game diff, opponent. All right. I'm going to say try this. And if that whole thing doesn't work, you raise exception, say we didn't find it. Data not found for team week in the season. Now we could say, oh, that should be the exception. Now we could say if retrieval, so if we want to test that function, then we're going to go ahead and do retrieve. And let's just get an early online in the data set. Let's go get Houston week 1, 2007. Houston week 1, 2007. All right, Houston, week is 1, season is 2007, and data is equal to pd.readExcel of data.xlsx. And then pass that data into here. And then we're going to print this variable. We just call it A, then go ahead and print that. All right, now gotta make this Boolean true. Let's run it. Um, should be dot values dot item dot values dot item. All right, now let's run it again. All right, so let's make sure that this is correct. All right, so first, so it's getting it for Houston. Houston's the away team. Houston week 1, so it's getting it for this game. Let's put this over here. Okay. Why can't I make that any smaller? Okay. I know I've made that smaller before. That's so stupid. Python 3 spread. All right, I'm just gonna run it in here again. What's the file called again? Functions.py. No such file or directory. Okay, so we're getting data for Houston week 1, 2007. So Houston, week 1, 2007. Opponent, let's just start at the top. So, all right, first thing is performance against spread. It says they beat it by 14. So Houston, where are you? That's week 2. All right, here's Houston. So Houston beat Kansas City 20-3. So they beat them by 17. And they were 3-point dogs. So they beat the spread by 20. Huh? Houston won by 17. Oh, Houston lost by 17. Okay, so Houston lost by 17. They were 3-point dogs, which means they came 14 points under the spread. Performance against spread, data of road close spread plus data of away score. Huh. Performance against spread should be minus 14, not positive 14. Data of road close spread plus. So if we go the away score minus the home score, and then, so if the away team was underdogs, and the away score minus the home score is minus 3, away score minus the home score was minus 3, and the road close spread was plus 3, then the performance against spread is 0. Here the road close spread was plus 3. Then away score minus home score Away score minus home score is minus 17. So how do we get plus 3 minus 17? There's some plus or minus we have mixed up. Um, all right. What, what, where's our negative getting mixed up? So first thing, let's just look at it. So home closed spread. So road closed spread here is plus 3. Okay. Plus data of away score, which is 3. So plus 3 plus 3 is 6 minus data of home score, which is 20. Now, why is that returning positive? Performance against spread. It says they beat the spread by 14. All right, whatever. Let's just go to the next one. So performance against total. Total points was 23. The closing total was 37 and a half. So they came in 14 and a half under the total. That's right. Spread swing. Road close spread, road open spread. So the spread swing for this game went from -1 to 3, so the spread swing would be 4. Again, wrong sign. Spread swing would be should be 4, meaning it's moving in favor of the home team. So spread swing equals road closed spread minus road open spread. Now how does that get messed up? Road closed spread minus road open spread. How does that return -4? If the close is 3 and the open is -1, it should return 4. So we're dealing with the away team. This is just honestly, unless it's saying otherwise, if let's just print whether this is true or not. Okay. Oh yeah, delete that semicolon. False. Data.awayteam.values.item is equal to team. But it's still getting the right game. Print data.awayteam.values.item is equal to team. Data is equal to... All right, let's just put the debugger in here. Okay. Now instead of this print statement, we're just going to put the debugger in. Data dot head. What the hell is going on? Data dot HEAD. What? Why do they keep doing that? Data. Data dot head. Um, data dot keys. Holy shit. Why does it keep doing that? Something's wrong. Data dot away team. Kansas City is away? Oh, damn it. That's so stupid. God. Okay. So Houston's home. So Houston beat them by 17. Houston beat Kansas City by 17. And they were favored by 3. Okay. So it works. So they beat the spread by 14. It makes sense. Okay. Now performance against total should be the same for both teams. So for minus 14.5, that's right. Uh, what's minus 4? Spread swing. So home close spread minus home open spread is 4. So yeah, swung minus 4. Um, then the total swing swung minus 1. The what's 27 again? Score differential? Game diff opponent. Um, so game diff is not 27. It was 20 to 3, so it should be 17. Game diff equals data of home score minus data of away score. I don't know how that could get messed up. Kansas City, Houston. Data dot home score minus data dot away score. So 17. Oh, what's the one before 17? One before score diff. Oh, odds swing. So the odds swung slightly, 27. Odds swing should be moving in favor of Houston. So odds swing is home. Oh, duh. Should be close minus open, not open minus close. Close minus open. And then up here, same thing. Close minus open. All right, back to here, and that should be minus 27. Yep. And then 17 is the differential, that's right. And then the opponent is Kansas City. So, just to make sure this works, we got Houston here. Now let's get Pittsburgh week 1. And let's take out that debugger line. All right. Data not found for Pittsburgh week 1. Data not found for team week. Why is that not printing? Exception. Data not found for Pittsburgh week 1 in the 2007 season. Okay, so let's just try to put this around the data isolation. Try that. If that does not work, do this. Now this can all go down. All right, and let's see how this does. Right, road score. So it's not finding Pittsburgh week 1, 2007. Why? And data.week is equal to week, and data.year is equal to season. Um, so if this try except, now why is it not getting the data? Data.where, data.away team is equal to team, or data.home team is equal to team, and data.week is equal to week, and data.year is equal to season. So that's not working. So let's go in here and see if we could figure out why. Oh, nice, a comment. For how many years have I been doing this job? I started in 2019 looking at data for fun for NFL betting, and it's kind of been on and off since then. Um, and now I'm just back at it again. I go back and forth. Sometimes I'll like, oh, I go back and forth sometimes. I like betting on games, so I'll bet on games. But the problem with betting without a data edge is that you're basically subject to your emotions, and you bet emotionally. It's hard to turn yourself into a computer and just make cold calculated bets. So I like betting, and I think that there's an edge in it because most bettors bet emotionally. So if you're using numbers and most people are just betting on how they feel, then you can kind of get an advantage over them. And the market, it's a free market, so the odds move according to how most bettors bet. And if most bettors are betting emotionally based on how they feel, then the odds are going to move not according to statistics or what's like probability models don't control how the odds move. Uh, Emotions control how the odds move. It's like the stock market. So if you get a numerical edge, you can make money. If you don't have a numerical edge, you probably lose money unless you're like really good at it, which most people aren't. Um, so anyway, thanks for the chat comments. Um, okay, so going back to where we were at. So what do we want to do? Oh, we want to figure out why is it not retrieving the data that we want to get. So we could go into Python, import pandas, and say data equals, import pandas as PD, and say that our data is equal to, we're going to read an Excel file. That's our data file. XLSX. Okay, now data.head, data.where, and we want to index where data.week is equal to 1. Um, and actually, we want to see where data.home team is equal to Pittsburgh. And then we want to drop it. Okay, so that gets us 121 rows. Now we also want to get where So we want to get data.homeTeam equals Pittsburgh, or we also want to get when the away team is equal to Pittsburgh. So that had 121 rows. This should have about twice as many, about 240 rows. Yes, 241. Okay, so now we're getting away and home data, and we also want to specify, we want week to be equal to 1. Okay, data.homeTeam is equal to Pitt, data.awayTeam, and the final condition that we're adding is that data.season, data.year is equal to 2007. Home team is equal to Pittsburgh or away team is equal to Pittsburgh. So this isn't quite getting exactly what we want. I think we want to put another pair of parentheses around here. So it gets us only one game. Now, why doesn't that work here? Data.where data.away team is equal to team, or data.where data.home team is equal to team. Wrap that up in parentheses. Okay, and data.week is equal to week, and data.year is equal to season. Dot drop NA. Now here I do that command, and it works. Data.where am I putting in Pittsburgh week 1, 2007 data. Yeah. So what's wrong with this? Oh, could it be? Might not be reading in the data because I had it open. Let's see. That would be the dumbest thing. All right, let's exit and let's run it. No data found. Retrieve Pittsburgh week 1, 2007 data. Well, okay, so next thing is if we take out the try except loop, it will give us the line that fails. Now let's run it. Where does it fail? I can't find the road score. I bet I'm using the wrong key. Come on. Yeah, it is a way score. Okay, so oh. Okay, so if data.awayTeam.values.item. Right, but then when we had the print function in there, that wasn't working either. A is equal to retrieve game diff is equal to data of road score minus data of home score. Okay. That's not road, that should be away. Now, does it work if we run it? Oh, nice. Okay, so let's put the try except back in. And then we could indent all of this. All right, now exit out of the data file and run it one more time. Okay, so now just to verify that this is correct, let's go make sure these values are right. So Pittsburgh played Cleveland week 1. Is that accurate? Pittsburgh was away. They were at Cleveland. That's right. Their performance, let's go look at the values again. So first one's performance against spread. Performance against spread we got was 22. The road close spread was -5, so Pittsburgh was favored by 5, and then beat Cleveland 34-7, so beat them by 27, which means they beat the spread by 22. Yep, that's right. Next one would be performance against total. 36, and the total went to 41. So 4.5 over, yep. Spread swing was -0.5 point. Yep. And then what's the next thing? Total swing. How much did the total swing? -1 point. Yep. And then odd swing for Pittsburgh. Road open odds, road close odds. So yeah, moved. What is that? -14. Yep. And then last thing is the differential in the game. So they beat Cleveland by 27. Yep. And then the opponent was Cleveland. Yep. So our function works. Let's go ahead and knock that off the board here. Got all of those values that we wanted. Now that's done. Okay. So we have our function we want. Now let's put the next high priority thing in there. Look at how perform analysis on analysis 1 trend 2 to see how performance does from 2016 to 2021. All right, so what we want to do for this, the trend analysis 1 trend 2 is, oh, I said trend 2. Yeah, I should have said trend 3. So we're going to do trend 3 to see how performance does from 2016 to 2021. All right, so how do we define this region? Define a region. Define a region on a scatter plot. So we want to look and we want to say, oh man, this is hard how to automatically define the region. We could, so what could we do? We could say, let's define it by a little bit of an offset from there. Man, back to this. So our choice is to define it manually or automatically. Alright, back to here. We could exit out all these tabs. See how the stream is doing. Is anyone watching? Wow, 17 views. That's good. Oh wow, people are viewing now. Thanks for watching. Okay, so back to this. The problem, so to do this, figure out how to define desired region. So this I'm gonna add here. And we might have to do it automatically. So this becomes bottlenecked. And let's move it to here. Bottlenecked until I can figure out how to define that region. Okay. This is a bottleneck reliever now. Performance against spread does for each team in the season. Performance against spread. Oh, okay. So over the course of the season. And okay, and the other thing I'm doing is perform same analysis as yesterday, but with performance against total instead of spread. Okay, so this is high priority, and also, so we want to look at how performance against spread for each team does in the season. We also want to look at how performance against total does for each team over the course of the season. Okay, and that will also make high priority. Performance against spread does for each team in the season. Perform same analysis as yesterday. All right, now that just gets data for a team week in season. Now get previous data for a team week season num weeks and data. I thought, what is going on? Usually if I'm in Python and VS Code, it will, whatever. We'll just say this is a function for getting info on a team going back a certain number of weeks. Now how do we do the stuff over here? For index row in df.iterRows. All right, now, okay, so we're going to start out saying week to look for is equal to week. Now, while, now, first we're going to make a Boolean called still looking, starts out as true, and then we could say while we're still looking, what do we want to do? We want to say, we want to try retrieve team week season data. Try retrieve team week to look for season and data. Now, if we can't find that, all right, now num weeks found. Now, how many weeks have we found? Well, we're starting at 0. Now, if that works, then we're going to say num weeks found, going to increment it by 1. Now, if that doesn't work, we increment num weeks found by 1, and we also decrement week to look for by 1. No, that should be decremented either way. Except all right, so if we are unable to retrieve the data, so how many tries, I guess, have we made at the data? So still looking equals true. Num tries is equal to 0. Now, if we try to get the data, but it doesn't work, then we increment num tries by 1. If we while still looking, previous while still looking, try to retrieve it. If we successfully retrieve it, then we do num weeks found plus equals 1. And then we could say if num weeks found is equal to num weeks, then still looking is equal to false. Now, if we're unable try that. Except now if week to look for is less than 1, so week 1 is the first week of the season. So if the week we're looking for is less than 1, do we want to raise an exception? If week to look for is less than 1, we want to say, hey, unable to find data for team num, we could just say week to look. Yeah, unable to find data for team week to look for. Um, Now we want to try to retrieve it. If we're unable to retrieve it, then we increment the tries by 1. Now if we're successfully able to retrieve it, then we say num tries is equal to 0. And before we increment num tries by 1, we want to say if num tries is equal to if num tries is greater than 2, raise exception, unable to find data. Retrieve, so say A equals that. Now prev week data, or we could just call this past data is equal to an empty list. Now down here, we want to say that past data dot append, we want to add to past data A. If num tries is greater than 2, raise exception, num tries plus equals 1. Then we want to return past data. So let's do another test. Test get prev data is equal to 1. Change this to be equal to 0 to turn that off. If test get prev data is equal to true, then we're going to say copy that line to get our data. And then we could say that A is equal to get previous data. And we want to get Seattle, week 6, season 2007. Let's go back 3 weeks. And then we're going to print A. For item in A, print A. Okay. Now if we run this, dang it. Exited out of the terminal. Let's pull it back up, and then let's go to and let's run our functions file. Missing data. Nice. So, gets New Orleans for each game. Week to look for. Oh, well, we could decrement that either way. Now, let's think. So, if we try to get the data, and then we're unable to get that data for that week to look for should still go down by 1. Okay. Now let's run that, make sure it works. Huh. All right. Week to look for starts out as week minus 1. While still looking, if num weeks found is equal to num weeks, I'm kind of confused on why this won't work. Let's run it one more time and why does it's a different functions.py. What am I saying? For item in A, get previous data, past data dot append A. All right, now this is gonna take some thinking. Why is it doing this? Get previous data for Seattle. We want to get it from week 6, 2007, and we want to get the previous 3 weeks of data. For item in A, print A. We don't want to do that. We want to print each item. See if that makes it nicer. Oh, nice. So we could test this to make sure that this is right. Let's go to the data. The past 3 games. So it should be Pittsburgh, San Francisco, and then Cincinnati. So week 6, 2007, Seattle plays New Orleans. So the week before was week 5. Oh, we forgot to also return the value for if we're home. So let's go add this as well. Home, close the list, save it. Now let's run it. Nice. Okay. So that gets previous n weeks of data. Oh yeah, so we want to see, did they play Pittsburgh? They should have played Pittsburgh, San Francisco, Cincinnati. So week 5, Pittsburgh, yep. Now week 4, San Francisco. Yep. And then week 3, Cincinnati. Yep. So our function works. Okay, retrieve, get previous data. Now define, perform total analysis. Num weeks and seasons. So the total analysis for this should be, we should say data is equal to pd.read xlsx data.xlsx. Not that. Read, not xlsx, just read Excel. Now we have the data. We can say for row in data.iter rows. And then let's select the data. Data.where data is equal to data.where data.week. Let's define a minimum week to look for. Minimum week to look for can be derived from num weeks. And then data equals data.where data.week is greater than or equal to min week. And then min week is equal to num. So if num weeks is 1, then the min week is 2. If num weeks is 5, then the min week is 6. So min week equals num weeks plus 1. Min week, so if we want to go back 2 weeks, then the minimum week is 3. Yeah, that's right. So, and then drop where that's not true. For row and data.iter rows, where data.week is greater than or equal to min week, and then drop it if it's not equal to that. And then for each row, which is really just each game, home team equals, okay, so let's copy that. Home team is equal to home team, away team is equals to away team. All right, now for team, C team in enumerate, home team, away team. All right, so for each team, we want to say, all right, performance equals get previous data. Team week season. All right, so team right week is equal to row dot week team get previous data team week season num weeks data. Original data. Now data equals original data dot where that. Now performance equals get previous data, and the data we use here should be the original data. Okay, so we got the performance. That's fine. Now total performance. And let's go down here to see how to manipulate this. Put the debugger in, I mean. Right, A of 0. And we want to get performance against total. 0, 1, 2, 3, 4, 5, 6, 7. Oh, performance against total. Um, okay. So what do we want to look at? Performance against total or total swing? I guess total swing. So 0, 1, 2, 3. Hmm. Okay, now let's figure out how to index sublists within a list Python. Why don't we just return this as a pandas dictionary? Or, sorry, a data frame. Because, all right, so I'm going to write this to a dictionary, then I'm going to write it to a data frame, because that will make doing calculations on it after the fact a lot easier. Performance against spread, performance against total is PAT, performance against total. Right. Total swing is total swing. What else do we want? Odd swing is odd swing. Forgot to change this. Don't want to miss any more chats. Odd swing is odd swing. Game diff. Opponent is opponent. Home is home. Okay. Now info is equal to, this is just info data. Info is equal to pd.dataframe of info data. And then this we can comment out. We could say return info. Now get previous data, test get prev data. Yeah. So let's test this now. Continue. Okay. Data not found for Seattle week 2 in the 2007 season. Data not found for retrieve team week to look for season data. Hmm. PD.data frame of info data. If using all scalar values, you must pass an index. Um, yeah, I guess we could just return info data. Or I guess we don't even want to return that. This is in the game thing, so get previous data. All right, so I'm trying to think of how to organize this. So keep organizing it that way. Um, Now we're just stuck with this past data. It's a list for each thing. Um, I'm just thinking. I have this big scab on my knee. All right, so how are we gonna handle this? Now, we may as well just deal with it all in here, I think. All right, let's run that file again. A. So now we have A. How to get sublist by slicing a Python list. What if I have multiple lists in a list? Uh, Print the original list, string of test lists. The original list. Huh. All right. We could just say I for I in A. Um, Now this is a list. Um, all right. Now we have I for I in A. Oh, nice. J for J in I. For I in A. J for, ah man, dude, this is a nightmare. Um, So we could change this function, get previous data. Now past data dot append a. So a is equal to retrieve past data dot append. We want to append past data. Oh, we could say past data equals turn I into a list. Now, if week to look for is equal to week minus 1. So if we're on the first week, what do we want to do? We want to say that past data dot append a list of I for I and A. And then we could say else for item in past data for C item in past data item dot append item dot append A of C. Well, let's look at how that works. Hmm. Hmm. For item in A, past data dot append now we're saying for each item. Now there's a bunch of lists, but then for C item, for item in A, past data dot. All right, now let's see if this is any different. Now we have nothing in there. So for item in A, if A is equal to that. Now for item in A, past data dot append put item in a list and append it in there. if week to look for is equal to week minus 1. If we're on the first week. Otherwise, for C item in past data. All right, now let's just put the debugger in here and run it again. That's what I don't get. So all right, so now we could say Q is equal to a list of I for I in P. Now what's Q look like? Now for list in Q, list dot append, oh, 1. Oh, huh. For list in Q, list dot append 1. Now we could say for item in past data, item dot append. What is happening, yo? All right. Now past data is a list of lists. So for C item and past data, item dot append A of C. Oh, damn, yo. This should be enumerate. And enumerate past data. All right, now let's run it again. What the hell's going on? All right. Save it and run. Continue. Okay, is that what we want? For item in A, print item. All right, we gotta, I think that looks good, but we gotta test one more time to make sure this is what we want. A, 16, 18, 0. Yeah, so 16, 18, 0, Pittsburgh, San Francisco, Cincinnati. 16, whoa, minus 16 it should be? Yeah, minus 16, 18, 0, Pittsburgh, San Francisco, Cincinnati. Cool. All right, now this is the one that we want to return as a data frame. So let's go back here. A of 0. Okay, very good. So back here, get previous data. So now we've got past data. So info is equal to pd.data frame. All right. And what are the categories in order? Oh, nice. So info dict is equal to that. And then that, but we could say pass data of 0, pass data of 1. Should just copy and paste that in there. Pass data of 2, pass data of 3, 0, 1, 2, 3, 4, 5, 6, and 7. Yeah, that should be good. And then info is equal to pd.dataframe of info dict. And then we want to return info. All right, now see what that looks like. Um, um, all right, now, all right, where are we? Now we just want to say print A. All right, now what's that look like? Nice. Oh yeah. Um, yeah, cool. Easy. All right. Points against spread, points against total, spread swing, total swing, odds swing, game diff, opponent. Now the question is, do we want to, we could add everything right now to incorporate everything to be simple. Do we want to do that now? We could make, I mean, no, actually, I think that's fine. I keep getting distracted. Let's focus. Let's try to drive progress and finish what we're trying to do. So now we want to look at how performance against total does for each team. Perform same analysis as yesterday, but with performance against total instead of spread. Okay. So let's write, change that to 0, and let's make a new script. Let's go save it in our workspace as total analysis.py. File for analyzing performance against total. File for analyzing total swing as a function. File for analyzing totals. Analyze things we analyze are total swing as a function of previous total swings. Total swing as a function of previous performance against total. Performance against total as a function of previous total swings. That doesn't even give us much. So then we want performance against total as a function of previous performance against total. Going back 1, 2, and 3 games. All right, so make a plotting function. All right, then we could say scatter. Add these 2 lines in so that we can see where 0 is. All right. Okay. Then we want to make the title of the plot. Title, okay. Now, put this back over here and look at functions. I forgot we were doing this here. So get previous data, test get previous data for row and data. Oh, that's stupid. Okay. Num week season for C team and enumerate home team, away team. Min week equals that data dot where. But we not only want where the data, where the week data is greater than or equal to min data, we also want data where data dot year is equal to season. Okay, so for each row, get the week for C team. So for each team, get previous data for that team. Now, total performance. All right, so let's say key is equal to home if C is equal to 0, else away. So then perf of key is equal to performance get previous data. So then when we do get previous data, PAT dot mean. I mean, let's test get previous data. Change that to 1. Change that to the debugger right here. And let's look at how that does. Perf key is equal to performance. That doesn't have a key. Just save that. Now let's run it again. Oh, make an empty dictionary for performance data. All right, back here, run it again. All right, now we could say a dot performance against total dot mean cool dot pat dot mean. So up here, perf of key is equal to performance dot pat dot mean. So the mean performance against total. Okay, now we have that. Now for C team in enumerate home team away team. Okay, now previous performance against total diff is equal to previous performance against total difference. I need more coffee. Is equal to perf of home minus perf of away. Okay. And then the other thing we want to look at is how much the total swings. So previous performance against total difference is equal to performance of home minus performance of away. We actually want to append that. Perform analysis, num week season. Yeah, so the val should be one of all right. Just cleaning this up so it looks nice. All right, now. All right, now these are the valid values. Now, we could say if val not invalid. Vals raise exception. Val not valid must be one of I for I invalid vals. Okay, and then instead of .pat, you just do of val mean previous pat diff append so previous diff append means that we're getting, yeah, and then how much it's changed for each team in their last n games, and then game diff is equal to row dot home score minus row dot away score. Total swing is equal to row of closing total minus row of opening total. Now let's prove diff.append. Get previous data, retrieve team week season data. Perform analysis, so val should be x data, we could say val is equal to x data. And then we have y data and x data, and then we can say y data should be one of what? So we have x data, we want to get y data, should be spread swing, odds swing, total swing, performance against total, performance against spread. Yeah. Okay. Valid y data is equal to spread, swing, odds, swing, total, swing, performance against total, and performance against spread. Spread swing, odds swing, total swing, performance against total, performance against spread. Spread swing, odds swing, total swing. Retrieve team week season data. So then we could say game data is equal to retrieve. That's just going to be less efficient. So let's just do that. So what do we have? We have total swing, no. Spread swing. Spread swing is equal to row of, yeah, that's going to be a huge pain in the ass. So just going to say game data is equal to retrieve team week season data. Retrieve team week season data. So we want to get the home team, because we want to get the home team's performance against spread or total or whatever it is. We want the home teams. I think we do. There's our PowerPoint. Spread swing for home team. Yeah, so game data is equal to retrieve home team. And then team week, week. Row, so week is row dot week. Season is just season. And then data is our data dot week is greater than, so we're gonna say data is data. Or just to be safe, original data. All right. Now, vowels is equal to, so we're going to get a dictionary of vowels. So we're going to go spread, swing. Valid Y data. So all right, if valid, if, forgot to add this here, so if Y data not invalid, Y data, raise exception, Y data not valid for Y data, must be one of I for I in valid Y data. Okay, so we have that exception handled. Now, game data is equal to retrieve. Now, if Y data is equal to spread swing, Y val is equal to game data of 0, 1, 2. 2. Elif Y data is equal to total swing. Oh, we could say odd swing. Y val is equal to three. Odd swing, Y val is game data of 3. 0, 1, 2, 3. So that's total swing 4. Elif Y data is equal to total swing then we have game data of 3. Spread swing, odd swing, total swing, PAT is equal to PAT. Y val is equal to game data of PAS, PAT. So this one's 1. And then finally, elif Y data is equal to P performance against spread. Y. Oh man, I just realized fantasy football is starting. I have to make sure my lineup is set. Oh man, I hope it's set. Oh man. Well, hopefully my guys do good today. How's Madison doing? Yeah, well, I hope I win in fantasy today. Alright, so Y val, that's not double equal. Y val should be single equal. Y val is equal to game data of 0. Alright. Yeah, I should have made it a dictionary, but whatever. Now x equals that, y equals that. Now performance of val, yep. So x dot append prev diff, and then y dot append y val, and then want to perform the analysis. Yeah, let's just add it in at the bottom here, may as well. All right, Now we're going to say from matplotlib import pyplot as plt, plt.scatter xy. And then we want to say x label is game diff, so val. Alright, so x label should be average x data. Average x data, average blank, last num weeks. Oh, yeah, no, yeah, we're good. All right, so plot.scatter x versus y, plot.x label, average blank, last blank games, home minus away, and then plt.y label is f of home team y data. And then plt.title is what do we call that? Last average x data, home team y data. So we could say y data as a function. Yeah, y data v x data last num weeks games and then season. So like 2017 or 2007 season, whatever you want. So there's our title, and then plot show. All right, now perform analyses. Perform analyses is equal to 1. Now we're going to say down here, if perform analyses is equal to true, what we want to do is for I in list is 1, 2, 3, 4. 1, 2, 3, 4. So for I in that, perform analysis, num week, season, x data, y data. Perform first thing we want to do is clear the plot. Perform analysis, and we want to get I number of weeks back. Season should be, let's go 2018, so it's more recent. X data should be Performance against total and also total swing. So we could start out by making X data total swing. And then the Y data should also be total swing. Okay, then we also want to do the same thing, but instead of, so we still want X data, what do we say? We want X data performance against total, and we want to do total swing as a function of total swings. So total swing, X data, Y data. So here we're doing total swing as a function of total swings. Now, previous total swings. Now we want to do total swing as a function of previous performance against total. And then finally, we want to do the analysis of total swings. 2018 total swings as a function of previous performance against total, and then finally performance against total as a function of previous performance against total. Okay, now that we should be able to let it run while we go do other stuff in the background. So let's do Python 3 functions.py. Why does this keep doing that? I'm just gonna exit out, go to a different tab. All right, so now we can say Python 3 functions.py. 113. Data equals original data dot where. Original data dot week is greater than min week. Original data dot year is equal to season. Okay, nice. Now let's go do that again. Tuple object has no attribute home team. 119. For row and data dot iter rows, row dot home team. Let's just put the debugger in there. See what the issue is. Row dot home. So what's type of row? Is it tuple? Row of 0 is that. Row of 1. Type row of 1. Nice. So for row of 1 in data.iter rows, okay. Past data of 0, 74, line 74. Oh. Past data. Infodict is equal to info data is equal to all right, now what's past data? All right, let's put the debugger in there. All right, now past data is equal to that. So if we do past data of 0, all right, so we're gonna print team week season. All right, so print team week season. Print team week season past data. All right, now let's exit out of here. Do a new terminal. All right. Now what does a week? So for Carolina, week 5, 2018, it fails. All right. Now why is it doing that? Carolina, week 5, 2018. Okay. So there's Carolina, week 5. Oh, 2007. All right. Gonna have to go way up in here. 2018, week 5, Carolina. (2018) week 5, they played the Giants. 2018 week 4, Carolina didn't play. 2018 week 3, 2018 week 3, Carolina did play. Cincinnati. So while still looking, if week to look for is less than 1, try print week to look for. Yeah, so for each one that it goes through, print the week that we're looking for. Now, okay, so before it prints out that team week season past data, it's got nothing for past data. I think, is this Carolina playing Tennessee? Carolina's playing the Giants. Okay, so Oh. All right, still looking. If week to look for is less than 1, still looking. If num weeks found is equal to num weeks, still looking is equal to false. Num weeks found is equal to 0. Try print week to look for. Num weeks found num weeks found print week to look for as well as num weeks found. Wrong one, wrong terminal. Pull the chat back up. Hi, Adam. Adam, thanks for hearting this. Thank you, Adam. Adam. Your heart has now been pinned. All right. List index out of range. So what's the 76? So let's run this again. See where it fails. So let's see if print week to look for, num weeks found. So that should come up before that. Week to look for is 3. Num weeks found is equal to 1. If week, all right, print week to look for, num weeks found. All right, so now I found the data. Now if num weeks found is equal to num weeks, still looking is equal to false. It might be because that still looking is right there. But then if that was the problem, it should fail for the ones that don't have a bye week as well. Hi, Juan Miguel Diaz Gutierrez. Hi, good. What's it? Oh, thank you, Juan. Heart. I don't know. How do I... Sorry, Adam, but Juan Miguel Diaz Gutierrez said good job, so he gets pinned. But I don't know how. Oh yeah, nice. Sorry, Adam. Thank you, Miguel. All right. So, man. So, all right. Take out this debugger line. Now, when we're looking through here, it prints a 3 and a 1, which means, so it prints that it was looking, so it does find it. So we only want to print num weeks found after it finds it. I guess we'll print num weeks found also here, or print week to look for. All right, so now when we run this, all right, so we see at first it's looking for week 4. It couldn't find it, so it didn't execute this line. It just looped back around to here, and then it did this again. So then week to look for gets decremented every loop of the while loop. Now, so we start off we give it week 5. It says week to look for is week -1, so it's looking for 4. It's unable to find 4, so it loops around and tries to find 3. 3 works, it's able to find 3, and it continues through to this statement right here. And then it says it prints 3 again because that's the week we're looking for, and it prints the week found, which is 1. Now we've found the week. What's item? If week to look for is equal to week -1, oh, yeah, instead of printing this stuff, let's print A and see what it's returning. Because maybe A is just an empty list, in which case our problem is in the other function. Four, 3, oh, so we do get the list that we want. Now, if, oh, this is because it's doing if week to look for is week -1. Our week is 5, so it's saying if week to look for is 4, so it is returning an empty list because it's never writing to this. So instead of if week to look for is week -1, we can say otherwise if num weeks found is equal to the number of weeks back we want to go. I guess, yeah, that's not right. We want to say if num weeks found is equal to 1. So once we've found the first week, go through and write everything to here. Now this should work. So we could take out our print statements. All right, now let's save that and run the file. Damn, why am I still printing so much stuff? Oh, okay. Get that out of there. Okay, now we have an error, another error. Return. Perform analysis, plt.scatter xy. X and y must be the same size. So plt.scatter. Let's put the debugger in there so we can look at the sizes of these. All right, now it's gonna run real quick. I'm gonna go make some more coffee. Oh, never mind, I forgot the oh, I'm not printing anything. Are we in? Okay, so len cancel. Damn. I guess. How did that become a hotkey? So every time I press parentheses, or shift is hot, shift is paste key for MOBA xterm. How do we get rid of that? The paste text hotkey somehow got set to shift. All right. Nope, still happening. Nice. Okay, so len of x, len of y. So what is the problem? from matplotlib. What? This doesn't even make any sense. All right, now this, let's put in up top. Run it again. Now let's wait a sec. Come on, come on, come on. X and Y must be the same size, but they are the same size. So put the debugger in here. Let's look at the length of X again. Okay. So X dot append previous diff. Prev diff equals, oh. So you could just say X is equal to prev diff. Prev diff perf of home minus perf of away, yeah. No, this should work, I think. Oh, gosh dang it, man. Gotta take that debugger line out of there. And go back in here. Run the terminal. All right, now let's run this and hopefully a plot will show up. What? plt.scatter. Oops, didn't save it. All right. Back to this. All right. No. Fingers crossed, plot should show up now here. Nice. The only problem is we don't have our lines. How did I forget to put those in? Let's look at the labels and title to make sure everything looks good. Total swing versus total swing last one games, 2018 season average total swing last one games, home minus away, home team total swing. Nice. Okay, now we have our red lines that should be popping up. Exit out of here. All right, Python 3 functions. Now it should do the same plot with our red lines. Now we can let this analysis go run while we go do other stuff. All right, now let's put this in our PowerPoint. Now this slide I'm just going to call total swing versus previous average previous swing last n games. And the first plot is on here for the last one game. Okay. Now we'll do last two, 3, and 4 games. We'll also go in here and then we can do total swing versus average, and then what else do we want to do? Total swing versus performance against total, then performance against total as a function of previous performance against total. Oh, yeah. Total swing versus total swing. Last n games. All right, now it should do PAT versus total swing last n games. Total swing versus PAT, yeah. Total swing versus average previous swing last n games. All right, then total swing versus average previous swing. Then we have performance against total. This is swing versus performance against total. And one more slide for this guy. Should have just saved these instead of showing them. Yeah, you know what? That is what I'm gonna do. So let's go in and modify this. Retrieve, get previous data. All right, so for this plot in perform analysis, plot save name is equal to, should be string is equal to none. Now, if plot save name is not equal to none, then if plot save name dot split, split it there, get the last element, not in dot png dot jpeg. Then we need to raise exception. Plot type must be a picture. Plot save name not valid. All right. Now if it's not a valid save name, raise an exception. Otherwise, if it is a valid save name, that's the else line isn't necessary. Yeah, may as well. Otherwise, if it is a valid save name, go ahead and do save it. Let's make a directory called plots real quick. Okay, and we want to save fig in plots slash plot save name and put an F out front to make it a function string, and then show it if plot save name is not equal to none. Otherwise, go ahead and show the plot, and then plot save name here is equal to total v total okay, let's go in here, make some new directories. So cd plots ls. Now we want to make a directory total v total. We want to make a directory make directory total. Okay, let's get rid of that because it's not total v total. It's swing v swing. Then we want swing v performance against total. And then we want performance against total versus performance against total. Plot save name equals swing v swing slash I, make it an f string, I dot png. Now let's make this plot save name is equal to swing versus performance against spread. Slash I.png dot png, and then the last one, plot save name is equal to I.png. Okay, so let's see how that one works now. Exit out of there, and since we're not, the plots aren't popping up, we should just be able to do in the Ubuntu, since we don't need the MobaX term to view anything. Python 3 functions.py. Plot type must be a picture. Swing v swing slash 1.png. What's not valid about that? If plot save name dot split dot -1 not in, oh, there's no dots because we're splitting on the dot. So that should be good now. And run it again. All right, now we should see some plotting start to happen. Swing versus swing. We got the first one. First one for all of them. Nice. Total swing versus total swing last 2 games. All right. And hopefully, yeah, this is going way faster than that other code we wrote, so we've already sped it up a little bit. So while we're getting those plots, what do we want to do next? Oh, unable to find data for Carolina week 0. Okay, so it failed. No, we're trying to get the last 4 games. It failed because Carolina. So the question is, do we want to miss out on all of week 5 data just because Carolina doesn't work? Should we be happy? Well, let's just look at how this looks. Swing versus swing 3. Yeah, I mean, there's not much of a pattern to tell there. Let's look back here. Swing versus performance against total. Well, that one's a little bit more skewed. Average performance against total the last 3 games. Home team total swing. And finally, performance against total versus performance against total. Again, not much here. I mean, if we draw a box, we draw a line to the left of here, there's only one data point where the total's going over. Again, it's kind of hard to draw any conclusions from this. Yeah, okay, so we've got the total plots. Look at how performance against the spread does for each team in the season. Perform same analysis as yesterday, but with performance against total instead of spread. So that's done now. All right, now okay, now we want to look at how does performance against spread do for each team over the course of the season. So get previous data. Probably just do this in the terminal. All right. So we go into our directory. Open up Python. Now we could say, actually we should exit, change this so it doesn't run it every time. Now everything's just sitting here as functions. Now let's go Python 3. From functions, import get previous data. as G. Now we want to get previous data for Seahawks week 17, season, let's just say 2018. Num weeks, I'm gonna get the last 15 weeks of data. 14. Data, import pandas as PD. A is equal to pd.read Excel. Read our data file. Okay. Wow, that's actually really fast. All right, well, that's cool. That is really cool. So, we get that data frame. Now, what if we do that dot pat dot plot from matplotlib import pyplot as plt dot show. So yeah, I mean it's basically like we expected. It's a sinusoid. Um, maybe we might be able to get something out of this. That was really easy to pull up. So let's say define get season time series. Okay, and this should be a function to get, well, whatever it is, for the season. So for team, for season in 2007, 2008, 2009, 2010, 2011, 2012, 2013, and just do 2014. A is equal to G of SEA 17 season 15. Oh, A. This we could call B, and then we could say B dot B dot PAT dot plots. Then let's look at this plot. This is kind of hard to look at. The main point here is that you can see, if you look at a team's performance against the spread, it's not like it just, is always doing above the spread or below the spread. It fluctuates between going below the spread to going above the spread. So that's what we expect. Now, for season in that season, B is equal to that. Now we want to say plot. b dot performance against spread, and then label is equal to so plt dot plot. Label is equal to season. Turn the season into string, and that's the label. All right, now we've got that. Now plt.xlabel, game number, plt.ylabel, performance against spread, plt.subtitle, Seahawks, performance against spread 2007 to 2014. Okay, almost done. Let's do it one more time. 2014, 2015, 2016, 2017, 2018, 2019, 2020, 2021. All right, now for all these seasons, do that. Now plot it. Xlabel. Tw 2007 to 2021. Don't forget to show the legend. And then let's show the plot. Whoa. Yeah, that must have been the Xlabel thing. So, should have put it in a script, but whatever. One more time. What is the issue? For season and blah blah blah, b equals that. All right, now let's do for seasons. Get the previous games. Riku, get over here. The dogs are barking. All right, so plot. Okay, so plot it. Then we want to get Xlabel, but we're not done with that loop. plt.xlabel, plt.ylabel, and then the title. And the legend. Nice. All right. So Whoa, is this performance against spread or performance against total? Oh. All right, now let's make this one more time. Performance against spread. Gosh dang it, man. All right, so that's the performance against the spread. Just want to get the legend to another corner. Man, that looks ugly. Just trying to change the area of the plot so it looks nice. All right, now we have that. Let's put it in here. Okay, now I'm just adding the plot to PowerPoint. All right, now let's make the same plot but do performance against total. All right, and we didn't do total though. Let's spread again. I should start using a Jupyter notebook because that'd be way easier to mess around with all this stuff. Oh, do want performance against total. All right, so we had performance against spread. Now we have performance against total. And just as I expected, it's kind of sinusoidal. Moves above and below 0. Um, Now let's put that in here. Okay, so now we have performance against spread and performance against total. Done and done. All right, now we want to look into machine learning. Before we do that, oh, to find regions to take bets in. So figure out how to define desired region. That's probably highest priority right now. And that would also be high priority. Now, okay, so you've done a fair bit of coding so far. I've been streaming for 3 hours or so. No, I guess almost 4 hours at this point. Yeah, it's been about 4 hours, maybe even over. So that I'm gonna call that it for this stream. So what I'm gonna do is wrap up here, get some things to do for the future, and then next stream I'll just pop up here and then I'll start doing stuff. So figure out how to define desired region is the top thing. Um, Look into the machine learning. We could take that out because that's kind of the same thing. Speed up code. All right, so density of points. So like define an area with a high density of points. Could also use machine learning to define bound manual rules to define bound. Okay, then speed up code. That is moving down here because the new functions I wrote today are fairly fast. Sorry, I'll scoot up, get back into frame. Get new data set where rows are bets. That's down at the bottom too. Try last n weeks spread as input to neural network. This is interesting. The question is which one of these should go first. So last n weeks spread as input to neural network. That is interesting. Figure out how to define desired region, see if I can formulate my own ELO ratings. Find more data to get for ML. This is also medium priority. Perform analysis on analysis 1 trend 3 to see how performance does. All right, so next stream I think I'm going to jump in, start working on this. Once I finish that, this will relieve the bottleneck here. So I can do that, and then once I finish this, we're going to go over and try last n week spread as input to neural net. So thanks for watching. We made some good progress today. I'll be streaming again tomorrow to make more progress. Thanks for watching.